So today's homework, or flipped lesson, is why can we hear someone through a doorway that we can't see? So here's person A, who's in the room, and here's person B, who's outside the room. Person A is singing la 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 la, and person B can hear that through the doorway being here, but they can't see them. So person B cannot see person A, and person A can't see person B, but they can hear them. Why is that? The answer is all to do with diffraction. Diffraction is where waves spread out after going through a gap. Now, light and sound are both waves. Sound has quite a big wavelength, and it's very similar to the gap in the doorway. So when the sound waves come off person A, when they get to the gap, they spread out. And so person B can hear person A. On the other side of it, light has tiny, tiny wavelength. So when the light is reflected off person A, the wavelength is tiny, 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 and nowhere near the size of the width of the doorway. So consequently, the light waves do not spread out. If person B was moved up a bit, then person B would be able to see person A. The wavelength of light is millions of metres. It's roughly 500 nanometres, which is 0.0000005 metres. The wavelength of sound is about a metre. And the key thing about diffraction is that the gap needs to be either smaller than or the similar size to the wavelength for the waves to spread out. If the gap is much bigger than the wavelength, as it is for light, then the waves will not spread out. So, just to reiterate that, diffraction is most observable when the gap is either the same size or smaller than the wavelength. And what's the symbol for wavelength? Lambda. So person B could not see person A because the wavelength of light is tiny compared to the gap, but the wavelength of sound is similar to the gap, which is the doorway. Therefore the sound spreads out, but the light waves don't. And that's the end of today's flipped lesson.